Hmm. Okay, let's start with the linear programming problems. In the linear programming, we will talk, first of all, we will talk about the basic assumptions and problem formulation. We will not do lots of questions based on the formulation as you might have done in the 12th. Even in the class, we have discussed a lot, but still, if you want me to discuss more about the problem formulation, then let me know. I will make a separate video for it. But as of now, in this only we will talk more about the simplex method. Right? And but a little bit one or two questions we will talk about the problem formulations basics of the LPP so that you are able to recall the things which you have done in your previous classes. So let's start with mathematical techniques used for optimum, maximum or minimum allocation of the limited or the scarce resources such as maybe labor, material, machines, money or land to several competing activities such as maybe for the products, for the services or maybe jobs or etc. on the basis of the given criteria on the optimality. Just understand if in my house I want to go ahead with the painting. I want to paint my house. So for that I need the services. Services of whom? Labor. I think lots of labors would be there in the market, but the one who is skilled into it and I have to pay to them. And at the same time, the people might be asking the different prices. At the time I need, it should be the minimum cost. I want my optimization or I want my services to be at the minimum cost. And I want the good quality person, also the person who is going to give the quality services to us. That for that, I need the maximum satisfaction or the maximum work. So that's would be the optimization of maximum. Right. So in maximum cases, what we talk about the maximization of minimum case, both the cases we will do it or it's there in the syllabus, maximization, the minimization. What's suppose I want to get in ahead with some of my cases, I need the profit to be high, maximum. My objective function would be to maximize the profit. And if it's something cost, I want it to be minimize the cost. Or maybe the wastages. Don't want much wastages in my manufacturing company or something like that. In that case, we will ask for minimum wastages, right? So the general form of LPP may be written as, first of all, we will write optimize. What optimize? Maybe maximize or maybe minimize. I just told you when it's a profit case, generally we say it's a maximization of the profit. If it's a cost, then say minimization of the cost or the wastages. So, and in that case, uh, we say that's an objective function. Z is an objective function. Objective function. Then we have C1 x1 plus C2 x2 plus C3 x3 plus so on is Cn xn, where this x1, x2, x3 and so on xn would be your decision or structural variables. The variables which we need to identify. I need to take the decision. How many I need to prepare X1, variable X2, X3. It may be anything. If I am the manufacturing company, then I might be having X1 as a table. It might be chair, it might be bed, it might be sofas, or so on. Right? So these are the decision or the structural variables which we need to, how many tables I need to prepare, how many chairs, how many bed, how many sofas, like that. Right. So this is my decision or the structural variables. But at the same time, when you talk about what is the CN, C1, C2, which are attached to that. So that is a contribution. Contribution. What is a contribution of that decision variable to the objective function? Or I can say profit. If it's a maximization case, then profit. If it's a cost function, then it's a cost. Profit or cost. Contribution is a to the profit or cost to objective function. How much contribution to the objective function? That is Cn of this variable, that particular variable. I think is clear. Then whenever we are writing for the LPP, we have the three major things. One is optimization. We have to decide and we have to write the objective function. Secondly, we will talk about the subjective constraints. In the subjective constraints, what are the constraints to it? Suppose we say a11x1 plus a12x2 plus so on a1xn xn, where it can be less than, equal to, or more than b1. Some of the constraint is given, right? So in this way, we have the different constraints. Suppose we have m number of constraints, we will write the m equations, right? Inequality equations are there. So in this, when we talk about this am1 or a11, what does it mean? They are known as technological or substitution coefficients. These are known as technological or substitution coefficients. And bm or b1, b2, these are the requirements or the availability of that constraint. Maybe we can say it's a requirement or availability of constraints. I think it's clear. So this is the second part. First part was optimization. Second part was we were talking about the subjective constraint. And then third and the last one is the objective function, this non-negative restrictions. In this case, this is known as non-negative restrictions. It is considered that whatever the value, this decision variables x1, x2, this needs to be more than 0 or equal to 0. Right? We have to write equal to also. Needs to be more than and equal to 0. Suppose I am saying my decision variable in my industry, if it's a manufacturing, it's a table. Then table can't be negative. It needs to be 0 or more than 0. So whatever the variables we are taking or considering decision variable, that needs to be more than equal to 0. So these three conditions are necessary for the optimization of, or in the case of LPP formulation. I think it's clear. Let me explain you. We get it by these things. You get the three parts of, or the three solutions. We get it. See, a set of values of the decision variables which satisfy the constraints of general LPP is called solution to the general LPP. If this is a general LPP, all the things are there, and if a set of values, we will get set of values of decision variables. हमारे x1, x2, x3, we get some values which satisfied all the constraints. मेरे सारे constraints को satisfied कर दें. That set of decision variable solution is known as solution of the general LPP. Is it clear? Now, any solution to the general LPP which also satisfy the non-negative restriction of the problem is called the feasible solution. The set of all the feasible solution constitutes what is called the feasible region. I think you have done these things at the time when you were solving by the graph of the two variables in your previous classes. So what does it mean? It's saying if the values of x1 satisfy their subject constraints or the constraints, in that case a solution. But at the same time, if it also satisfied non-negative restrictions, means these two, then it is known as feasible solution. And now, if any feasible solution which optimizes the objective function of a general LPP is called the optimum solution of the general LPP. It means all the three things, if it's satisfying, then we say it's a optimal solution, right? A solution may be feasible or not, we don't know. But if it's a feasible solution, then it's necessary to be the solution. We don't know feasible solution is an optimal solution or not, but an optimal solution is necessary to be the feasible solution. Is it clear? Sometimes the question comes up in the exam. Is the optimal solution is a feasible solution, or is a feasible solution is an optimal solution? How much confident you are? Or we can say it's a one and the same thing. So you have to explain it. Feasible solution satisfies the constraints as well as the non-negative restrictions. But optimum solution satisfied objective function of the general LPP also, along with the other two. That's the constraints and the non-negative restrictions. I think it's clear. Let's do one question on the formulation, simple one, and then we will directly try to go ahead with the simplex method. Let's see. A furniture firm manufactures chairs and tables, each requiring the use of three machines A, B, C. Production of one chair requires 2 hours of machine A and 1 hour machine B and 1 hour machine C. Right? So like that. Uh, mhm. हाँ जी. Okay. Now let's make it in the tabular form so that it's easy also. I just explain you. Right. Suppose it's a machine. We know there are how many machines? We have three machines. A, B, C. I'm writing machines are there. A, B, and C. At the same time, we have two chairs. Two furnitures are there. Chairs and tables. Okay. Then, because we have to calculate it, how many number of chairs we need to produce and how many tables we need to produce. Right? Then we have the read it. 1 hour for the machine. Profit realized by selling one chair is rupees 30, while for the table is rupees 60. The available total time per week on the machine A is 70 hours. So we can say available time per week in hours is given. Okay. Now write down the things, whatever is given. It's saying 2. Production of one chair requires 2 hours on machine A. Machine A may 2 hours. And 1 hour on machine B. And 1 on each machine and B and C. Each table requires 1 hour on machine A and B. Sorry. 1 on B and 3 hours on machine C. This is given, right? Now, profit realized by selling the one chair is rupees 30. We can say okay, profits per unit. That will be in rupees. For chairs, if they are saying, if you say you are selling one chair, then rupees is 30 profit. Here, it's a profit would be by selling one table would be rupees 60. Now, available time is also given. Total available time per week on machine A is 70. Is 70, is 40, and is 90. I think it's clear by the table. What all is given, I just converted into the table. And then I'm saying, let X be, let X be number of chairs to be produced per week. I think it's clear. And let Y be number of tables to be produced per week. And we should know X should be more than or equals to 0 as well as Y is more than or equals to 0. We all know it. So we can frame the equation. We can say 2x plus 2y is less than or equals to 70 as it is given. By two tables in a machine, we have the 2 hours and the tables we are x. It means 2 into x hours we can make it plus 2, not 2. It would be y. It's a one table, one y tables multiplied by 1. Because so we have available time is 1 hour with the machine A for the table, right? So it will become, and a maximum available time was 70. So it needs to be less than 70 hours. Okay? The next we can say is maybe 1x plus 1y less than equals to 40. In the same way for this, We can say x plus 3y less than equals to 90 hours on the machine C. Now, we can say the value of profit, let's say Z, and we know that Z is equals to that is 30x plus 60y, because x is the table, which is number of tables, and one, if we are purchasing we are producing one chair, then we're getting profit of 30 rupees. If we are producing x chairs, then it will be 30 into x profits. In the same way for the tables, if we are producing one table, then 60 rupees profit. But if we are producing y tables, then it will be 60 into y. Is it clear? Profit function. Then, can I say the mathematical form of LPP? Mathematical form LPP would be maximize. We have to decide first of all on the optimization. Optimize kya hai? Maximize. Why it is maximize? Because we want to get the more profit. So that's what it will be, the maximize. And it's necessary to write to maximize. Now, maximize equals to 30x plus 60y. Please, in the exam, don't leave only or don't start only by Z. Always write the maximization. Then you have to write subject to constants. ऐसा नहीं है कि आप कितना भी काम करो, कितनी भी चेज बना लो, क्योंकि आपके पास limitations हैं on the machines. You have some limitations on the machines. You don't have the 70 hours or more than 70 hours. And on machine A, you don't have more than 40 hours on machine B. You don't have more than 90 hours on machine C. So that's a constraint with you. You want the maximum profit. If there is no constant, you can continuously make it. But you have some constant and you have to follow those constants to optimize it. So what's the constants are? We already made the equations, which is less than 70. Another one was x plus 4 less than 40. Then x plus 3x less than equals to 90. And non-negative restriction, which is x and y needs to be more than and equal to 0. This is your mathematical formulation of LPP. I think it's clear. So now, like that, we have lots of questions, so we are not doing it formulation because I want to explain you the basics of simplex as of now. But still, if you need, I can solve this, but you let me know in the comment or even in the class. Okay, let's start with the simplex method. In the simplex methods, let's start first of all with the conditions of for application of simplex method. Sorry. Conditions for simplex method, it means when you can apply the simplex method. First, in order that the simplex method may be applied to the linear problem, the following two conditions have to be satisfied. What are those two conditions? First is RHS of each constraints should be non-negative. Right? So, if you suppose to take this example, if it is like this, 8x1 minus 3x2, which is more than and equals to minus 6. This is minus 6. Right? So we can't go ahead with this sort of questions. So because first step would be to convert that value into positive by multiplying by minus 1 on both the sides. If we will multiply both the sides with the minus 1, then we will get minus 8x1 plus 3x2 and 6. And then this is minus 6 will become 6, and just see the sign has been changed. Notice that the direction of inequality changes in the process. This is the basics of the mathematics. Now we have changed the sign, then we have to change the inequality. Direction of inequality would be also be changed. I think it's clear. Good. Now let's go for the second condition. Second condition say each of the decision variables of the problem should be non-negative. right? Any of the decision. Sometimes the problem might have the variable which is unrestricted or unrestricted in sign or free, so that it can be assumed negative values as well as the non-negative values. Okay? So if some such situation arises, in that case you have to handle it, or you have to treat it by such variables as a difference of the two non-negative variables. We have to add some variables in place of that variable as a non-negative, which are non-negative. Because such a difference may be positive, negative, or zero, doesn't matter, but the decision's variable, I can't take it as a unrestricted or the negative one. Suppose I take this example. This is 5x1 plus 7x2 minus 3x3, which are subject to constraints 2x1 plus 5x2 plus 3x3, which is less than and equals to 80, like this. These are the three conditions, and then x1, x2, x1 and x2 are more than or equal to 0, it's fine. But for x3, they are saying is unrestricted in sign. Means we don't know whether it can be positive or negative. In that case, since x3 is unrestricted in sign, we can represent it by the difference of the two non-negative variables. Means say x and y, we will consider another two variables. Let them be x4 and x5, and though both are needs to be positive or non-negative variables. Substituting, now we will substitute x3 in place of x3, we will write x4 minus x5. Now x4 and 5 may be positive. The value of x4 minus x5 can be positive or maybe negative or maybe 0. But in individually x3, x4 and x5 would be positive. If we simplifying, now our formulation of optimization of LPP problem would be maximize z equals to 5x, whatever the values we are, but we will add x4 into it. Now, wherever it was x3, in place of x3, we will write 2 into x3 clear, x4 minus x5. So it would be x4 minus 2x5. So has been incorporated here. I think it's clear. And it's a minus sign, then it's a minus and plus. So in the same way, in place of x3, we have kept x4 and x5, x4, x5, x1. And now all the variables x1, x2, x4 and x5 are more than and equal to 0. After the solution is obtained, we shall substitute the differences of the value of x4 and x5 as the value of x3. Definitely, we will bring it back. I think it's clear. Now, the application of simplex method requires, what are the things? First thing is all the variables are non-negative. Secondly, that none of the RHS value of the constraint is negative. Means replace any unrestricted variable by the difference of the two non-negative variables. I think it's clear. Two conditions. Now, let's start with the linear program, basics of the linear programming. Then we will take a break, and then we will start with the first question of simplex method, so that at a stretch we can explain. Now, first understand the basic concepts. In the linear programming, in the simplex method, generally what we do, we take the slack variable. What is a slack variable? It represents an unused capacity of that. Means a variable added to the left hand side of or the less than or equal to constraint into the equality. Right? Suppose I say there is a variable. It's given here only. Let me write it again so make you clear more. If it is x plus 2y, which is less than and equals to 30. Just understand, I want this equation to be equal to, right? So I can make it x plus 2y, I can make it equal to 30, means it's less than. 30 is more. If something can be added into it, then it would be equal. Let that something, which I am saying something to be added, that something is known as S1 or the slack variable or S. The variable added to the left hand side, or a less than or equal to constraint. Less than and equal to constraint is given, and we are adding something on the left hand side to make it into equality. That is known as a slack variable. और in economic terms, the business terms, slack variable का meaning क्या है, interpretation क्या है? It's indicate the amount of unused raw material या unused capacity. In this case, we are saying it's a machine. Suppose the previous question which we had done, we say this is a unused machine hours, right? So S1 is a slack variable. It is non-negative. Suppose 5 units of X and 10 units of Y are to be produced. Huh? Then 25 units of resources are consumed. How? See, हमने X हमारा 5 है, plus 2Y is 10. 10 units are produced. It's saying 5 units and 10 units are of Y are produced. It means we have utilized 25 units. 25 units of the resources will be consumed, and the slack variable should be set equal to 5, which represents unused capacity. Total capacity was 30, right? So means S would be 5 in that case. I think it's clear a little bit. How much is the unused capacity? You can say it's a 5. That's a slack variable. I think it's clear. Now let's understand what do we mean by the surplus variable. Surplus variable is also like that, but in this case, a variable is subtracted from the left-hand side of a greater than or equal to constraint to convert it into equality. We are also converting it into equality. The same sort of questions. To make it equality, if something is greater than, I'm saying x plus y is greater than and equals to 9. Right? If it is greater than or equal to 9, I want to make it equal. I need something to be subtracted from it to make it 9. It would be x plus 4 minus s, maybe s1, s2, s3, whatever the terms you want to, equals to 9. That whatever we have subtracted, that is known as a surplus. That was a surplusly was used. So again, always remember this surplus variable is a non-negative. It can't be positive. Oh, sorry, it can't be negative. It needs to be non-negative. Now, basic solutions. Another concept is a basic solution. The variable set to 0 if in any solution are called non-basic variables. ठीक है, variables are set equals to 0 in any solution. किसी भी solutions के अंदर if we set the variables equal to 0 in any solution, it's called the non-basic variables. The other variables whose values are obtained by solving the remaining system of the equations are known as the basic variables. जब हम इक्वेशन सॉल्व करेंगे सिंप्लेक्स के अंदर, उसके अंदर जो भी वैल्यू जीरो आ रही है हम उनको बोलते हैं दोज आर नॉन बेसिक वेरिएबल्स, और जिनकी जीरो नहीं आ रही है नॉन जीरो are known as basic variables, and we will bring to the table of simplex method. I will explain you when we'll talk more in detail, but as of now understand that part. Now, basic feasible solution to LPP is a basic solution for which variables solved for all greater than or equal to 0. That is my basic feasible solution. Right? So, I'm thinking to start with small question. Identify all the basic and the basic feasible solution of the following LPP. Right? Basic feasible solutions of the LPP. Maximize है Z equals to 3x plus 4y. Subject to constant is given. So first of all, let's say introduce slack variables. Which slack variables? Number of slacks variable will be equals to number of equations. So let's say variable be S1 and S2. And transform constraint set into the transform constraints. जितने भी हमारी constraint set है, may we have the two equations, constants, two constants are there into equivalent set. What it would be? It would be 2x plus 2y plus S1 equals to 80. What we have done, we have added the slack variables. Why slack variables we have added? Because the value is less than and equal to something to be added to make it equal to 80. So the second equation will become 4, 5 plus S2 equals to 120. Okay, so now we have the two equations, this one and this. The basic, we can say, basic solution occurs when two of the four variables in equivalent set are set equal to 0. Which two variables now? You have to decide. हम कह रहे हैं कि we have four variables now. What are the four variables? एक x है, y, s1 and s2. We have these four variables. We have to keep any of the two variables as 0, and then we have to calculate the rest of the two. So different possibilities हैं. Suppose we are saying we are keeping first s1 and s2 equals to 0. Let's do it. Then we will have the equations 2x plus 2y and plus s1 is 0. Then it would be 80. 2x plus 4y and solving it, and x2 is 0, it will come 120. Now solve these equations. It is minus minus. We will solve it. We will get this. 2y equals to 40. Sign would be y will be 20. So if we will replace this value of the y in any of these two equations, we will get the value of x to be 20. Right? So this is one of the solutions. But we can get number of solutions. How? Let's go for, suppose we have first solution would be when we are keeping s1 and s2 equals to 0. How many solutions we are getting? Then how many non-basic variables? I'm writing non-basic variables here because we are writing the to those variables to whom we have given the value 0. And here we will get the basic variables. हमारे basic variables क्या मिले? X equals to 20 and Y equals to 20. Now, second solution would be if we are keeping X and S1 to be 0. Let's keep X and X1 to be 0. हम इसके अंदर X को this X और S1 दोनों 0 हो गए तो हमारा Y equals to 40. हमारा Y 40 आ गया. And then we can calculate S2. S2 हमारा आ गया -40. इससे थर्ड सोल्यूशन मिल जाएगा x और s2 इक्वल्स टू 0. इस केस के अंदर हमें y की वैल्यू वुड बी 30, s1 की वैल्यू 20. सॉल्व कर लेना. इक्वेशन 4 solution 5 and 6 solutions we will get it because we have the NC2. Okay, then 4 is equals to, अगर 4 solution है तो y हम इसमें y और s1 0 रख लेते हैं, है ना. अभी लिख लेते हैं. और क्या y और s2 0 ले लेते हैं. We will can keep x and y to be 0. In these conditions हमारे इसमें x की वैल्यू would be 40, s2 would be 40, x would be 60, s1 would be minus 40. Would be minus 40. Here it would be s1 would be 80 and s2 would be 120. Right? So these would be your answers. So above, if we will summarize these, all the solutions possibilities, given that two of the four variables are assigned values 0, any of the two values we have assigned, right? But in this case, you will see solution 2 and solution 5. And solution 5, right? They have I have kept, right, I write asterisks over here. We have write the asterisks next to them. They are not the feasible solution. Not feasible solution. Why they are not the feasible solutions? Because as each of them contains a variable which has the negative value. You can see it's a minus, negative. One of the variables is negative, which is not possible. Means which is not feasible region. Suppose I have just made, however, we can say the other solutions 1, 3, 4, and 6. They are the basic feasible solutions. 1, 2, no, not the 2. 1, 3, 4, and 6 are basic feasible solutions. I think it's clear, but I've made one graph. Yeah. In this graph, you can see x, y, and when we plotted these two equations, we get these points 0, D, A, C, E, B, and which is equivalent to the formulations which we have done is 1, 2, 3, 4, 5, 6. If we talk about 1, 20, 20 is the point. This is 30, 40. Whatever the values we got it. It's the same values which we get over here. Right? So we can make it out. These are the, which are the feasible region? This is the feasible region which I needed. This is my reason. This 6, these are my points. 1, 2, 4. And you can see this 3, this point 2 is out of my feasible region. D is also the out of the feasible region. Is it clear? I think its concept is clear how to calculate it. Now find the basic solutions for the following equations. Two equations are given. Which of the solution is the basic feasible solution? Right? So we can make it as an easy one. Let me explain it very fast. First thing is when x is equals to 0, we can solve it. We have to keep a 3 are there. We will keep any one of them as 0. If we keep x as 0, then we can solve it for the rest of the two equations. Will become y plus 2z equals to 6. It will become 2y plus z equals to 10. Solve them. You will get the value of z equals to 2 upon 3 and y equals to 14 upon 3. That would be one case. Second case can be when you are keeping y equals to 0, you will get the values x equals to, please solve it. Take your time, no worries, but I am doing it a bit fast so that we can complete it. Then when we are keeping z equals to 0, x equals to -2 and y equals to 8, right? When you will solve these things, you will realize it, this value is coming 2. So 1 and 2 are the basic feasible solutions. We can say 1, this is 1. 1 and 2 are basic solutions are basic feasible solutions. ठीक है तो ये सारे basic feasible solutions, बस इसके अंदर basic feasible solutions are only these two. क्यों? क्योंकि इसके अंदर नेगेटिव में वैल्यू आ गई है वन ऑफ द वेरिएबल विच इज नॉट पॉसिबल. आई थिंक इज क्लियर. Then we will take a break, and then in the next session we will talk more about how to solve the maximization case, all the constants where all the types are less than and equals to 0, which is an important part from the exams perspective, right?